Hello guys, in this video tutorial I will explain and I'll teach you how to convert hexadecimal number, hexadecimal characters to binary numbers and digital numbers. And we'll use absolutely the same technique what I have explained in our previous video tutorial. So now my suggestion and my recommendation, watch a previous video and after that you'll continue watching second part, this video. Let's get started. As I told you before, hexadecimal number is this. So here, hexa means 16. Here we have decimal digits and letters, and combination of letters and decimal digits make hexadecimal number. And we call those numbers characters. Here, hexa means 16. We are starting from 0 up to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We cannot have 10. Instead of 10, we have A. Then we have 11, which is B. 12 is C. 13 is D. 14 is E. And 15 is F. If we start counting from including 0 up to 15, we have 16 characters. So each character in hexadecimal number, we have 4 bits long, each character. So let's take 5E. Each character, as I said, 4 bits long, and E also 4 bits long. Now, in our previous video, I explained how we were multiplying previous columns by 10 to make a decimal number, and how we were multiplying previous column by 2 when we have binary digits, bits. Here we have 2 characters, 5 and E. So here, because we have 16 characters, we are multiplying previous column by 16, starting column, 1's column, then we have 16th column, and if we have one more character, that would be 256 column, and so on. So we are multiplying previous column by 16. Now, to get 5, this bit should be 1, this should be 0, this should be 1, this should be 0. Indeed, this is 1's column, 2's column, 4's column, and 8's column. So 1 times 1 is 1, 4 times 1 is 4, and 4 plus 1 gives us 5. What about E? E is 14. To get 14, to get E, this bit must be 1. This also 1, 1 and 0. Indeed, 1's column, 2's column, 4's, 8's column. And that is 8 plus 4 is 12, plus 2 is 14. 14 is E. Okay, we translated. This is 5E equals 0, 1, 0, 1, 1, 1, 1, 0. Now, using our technique, Here we have 14, right? 14, because E is 14. 14 times 1 is 14. And this is 5. 5 times 16 is 80, plus 80. And we will get 94. Now, let's take down all those bits, all 8 bits here. 0, 1, 0, 1, 1, 1, 1, and 0. Here we have 1's column, 2's column, 4's, 8's, 16, 32, 64, and 128. 2 times 1 is 2. 4 times 1 is 4. 8 times 1 is 8. Here we have 16. And here we have 64. Let's add those values. 2 plus 4 is 6. 14. 20. 24. 2 is remainder. 2 plus 1 is 3. Plus 6 is 9. And indeed, we got this number. Absolutely same. So this means that we translated hexadecimal 5e equals decimal 94 equals 0, 1, 0, 1, 1, 1, 1, 0. We translated. Okay, and we used absolutely same technique what we used in previous tutorial. So we are because we have here hexadecimal number. Hexa means 16. So we are multiplying previous column by 16. Okay, let's take another example. 5. Okay, 5. Let's have this B. 5, 5B. Okay, so let's use same technique. 1's column, 16's. So 16 multiplying by 16 is 256. 256. Okay, let's use same technique. Now, 5, we know that 4 bits long, each character. Okay, now to get 5, we know that this bit should be 1, 0, 1, and 0. Same thing here. 0, 1, 0, 1. What about the B? B is B 11. So to get 11, we need 8. Then we need 2, and this is also would be 1. So, and this is 0. 5, 5B, hexadecimal 5B equals binary 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1. Now, we'll find decimal number using our technique. Okay, here B is 11. 11 times 1 is 11, plus 16 times 5 is 80. 56 times 5 is, let's use our calculator. Five times 256, 1,280. 1,280. Let's set those values. Here is 1, here is 9, this is 7, one reminder, 3 and 1. 1,371. So 1,371. We translated hexadecimal 55B equals 010101011011 and equals decimal 1,371. And let's check if we are correct. Let's take down 1010101011011. Okay, this is 1's column, 2's column, 4's column, 8, 16, 32, 64, 128, 256. That is 512, 1,024, 2,048. So 1 times 1 is 1. Here we have 2. Then we have 8. Then we have 16. Then we have 64. 256. And 124. 1,024. Let's use calculator. And we're going to add those values. 1 plus 2 plus 8 plus 16 plus 64 plus 256 plus 1,024. And indeed, we got absolutely same number. Okay, so we got same number. So this means that using our technique, we could translate hexadecimal numbers to binary numbers and binary to decimal numbers. I hope this video tutorial helps you to understand how to convert hexadecimals to decimal numbers to binary numbers, and vice versa.